Hey, and welcome to the Dynasty Empire YouTube channel. My name is Michael, one of the Dynasty partners, and today I'm going to be showing you how to make volumetric clouds like the ones you're seeing right now inside Unreal Engine 4.26 Preview 1. Now, I've already had to record this tutorial once, but then there were audio issues, so I'm not going to record it again, going through everything node by node, how to make the material. Instead, I'll be breaking it down into different sections and explaining the principles of each material and giving you a brief overview of how things are put together. And then at the end, I'll give you an overview of the final material. And on top of that, you can get all of the source files and the final result on my Artstation marketplace for free. So, starting off in an empty Unreal Engine project, all I have here is a cube for the ground that I've just scaled up to stupid values. I have a few other cubes and a mannequin and a point light just because there's no sunlight at the moment, just so you can see where we are. And in order to start getting things set up for the new volumetric system with the volumetric clouds, we need to get both a sunlight, a sky atmosphere, and a height fog in here. So let's start with those. Let's start with the sky atmosphere. So let's add a sky atmosphere and drag it in the middle. Nothing will happen because we don't have a sun to drive it yet. We also need a skylight. So we'll set that to movable, set that in the middle, and then we have this new feature on the skylight for real-time capture. For dynamic lighting, we're going to want to enable that so we can move the sun and watch the skylight update at the same time. So we can get rid of sky, and then the last thing we need is a directional light. So let's add this here, and let's set this to the center of the world. Set it to movable, so it's not having any issues with the shadows. And you can see it's still not lighting up the skylight. And let's move all of these into just my lighting folder. And that's because in this we have to tell this to be our actual atmospheric light. So where is that? Atmosphere sunlight here under atmosphere and cloud. Now if we tick that, you'll see that this is now scattering light through the atmosphere, or at least emulating light scattered through the atmosphere. Very accurately, and you can see it's updating the skylight in real time as I rotate the sun. And then one thing we forgot to add is our height fog, so exponential height fog. And this is all you need. You don't need an atmospheric fog anymore because the sky atmosphere also does what that does plus extra. So let's reset this to 0. And now if we rotate the sun, you can see it's still scattering light. We only have one issue, which is that the sun is only scattering the light in the height fog that is the in-scatter color that we define in the height fog. So we're not getting any of that gradient change from the sky atmosphere anymore. In order to fix this, we can go to settings, project settings, and then search height. And then there's a setting called support sky atmosphere affecting height fog. Now we enable that, we're going to have to restart, so I'll see you back in a second. There you go, my project has restarted. So now if I close this, and now if I move the sun, you can see it's still scattering, and that's because we have to go to the skylight. And we have to, yes, under the exponential height fog, apologies. We have to go to, now we can set these colors to black, because what they do is they add on top of the atmospheric scattering that the sky atmosphere does. So we have to set that to black and the directional in-scattering also to black as well. And now what we'll have is the color of the sky atmosphere affecting, driving the skylight, but also affecting the height fog. So now if I move this, you can see it looks like it's scattering things very realistically. And this is the base for how everything scatters really well inside of the volumetric sky as well, the volumetric clouds. So to get the volumetric cloud started, there's a new actor inside of Unreal Engine 4 called the Volumetric Cloud Actor. So volumetric cloud. Let's add this to our level. So let's add the volume clouds to our folder actually. So volumetric clouds to our lighting folder. And let's get started. Another thing we're going to need before we can actually make some volumetric clouds is we need some volume textures. There's quite a process to making volume textures. I'll link some resources by Ryan Brooks in the comment section below. But for now, we don't actually have to make any. If we go to settings and go to plugins and then search for volumetric and then enable the volumetrics and then go to restart. So I'll see you back in a second after the restart. So here we are, and you can see that nothing has really changed in our project, and that's because we have to go to view and show engine content, and all the volumetric content is here at the bottom under volume textures, and this is everything that we'll need. So you can copy these into your own folder. I've already brought them up into mine, so if I go to my clouds tutorial, here textures, and then I got volume textures. And then using those volume textures, I've made some examples to break everything down for you. So here's the most basic way you can make a volumetric cloud effect inside of Unreal Engine. But before we get into the full graph, you're going to need to know that the material domain name is going to have to be set to volume, domain type, sorry. And then the blend mode I set to additive. And since the lighting for the cloud is calculated in the ray marcher that is tied to the atmospheric sky as well, that we don't need the material to be lit, so you can set it to unlit. And as far as the volumetric cloud settings and the material attributes, that's all we need to know. And then you can see that this very basic material actually makes some simple volumetric clouds. And the driver of all of that is this volume texture here. It's a new texture type. So I'm going to show you some of those. I showed you briefly earlier, so let's have a look at this Veroni tileable, and let's get rid of the alpha. So what this looks like is, it looks like a tiling noise that kind of changes as it goes through, and that's kind of what it is. It kind of looks like a sprite sheet. But instead of like a sprite sheet, every frame is a frame forward in time. Every frame is the next slice of this volume, as if you're slicing it through slice by slice in one axis. Almost like a CT scan, if anyone knows how those work. And then what you can do is, so this is the end slice, this is the beginning slice, and it goes through. And then we have a new volume texture type, texture type called a volume texture, and you load that texture into this, and then you can, the one that we were looking at was Veroni, so let's look at Veroni, I believe. And then if we look at this, you can see it's the same thing. It's got a little bit of padding on the side to deal with mip mapping. Again, Ryan Brooks and the resources that he made resources that I'm going to provide below on how that works if anyone's interested to know more about how that works. But then we can also change the view mode type, and let's go trace into volume, and you can see that there is a cube here with the texture going all the way through, and there's no breakup on the edges here. It kind of goes all the way around, and that's because these textures are being written to this volume. If you took a slice through, like in this direction here, and then a slice, slice, slice all the way through, that's what you would get in the non-volume view of view mode and depth slice. So each one of these is a slice through depth. And that's how we're able to get the volumetric cloud effect rather than it just being projected in one direction. So let's add that material that I showed you. So here under examples, basic clouds, this is the first one. And all we have to do is actually just add this to our cloud material. And you can see we already have volumetric clouds from that very simple material that I showed you. And all we're doing in this is we have the well position. We don't need to mask any attributes because it's got 3 vectors, X, Y, and Z, since it's a volume. And then I'm just multiplying the cloud scale by a large number since it needs to tile a lot, so we can keep our numbers small. And then just doing some very simple maths here in order to be able to control the density of the clouds. So subtracting 0.5, multiplying by 2, and then adding alert between -1 and 1. And that allows us to keep the range for the coverage between 0 and 1. So 0 is no coverage, no clouds. 0.5 is half coverage, and then 1 is just full coverage. And then I'm making sure I'm clamping everything. I don't need a double clamp here, but it's fine because this is from another material. And then I'm just multiplying it by a number, which is our max density. And then that just gets multiplied by this simple little color setup here. And that goes into our albedo. And then we have this new node called a cloud sample attributes. And then what this normal altitude layer means is that the clouds have a minimum and a maximum altitude. And this creates a gradient through that altitude. So 0 is the minimum altitude and 1 is the maximum altitude. So this allows us to add a lerp, and then what this lerp is saying is that the clouds go from being white all the way up to being more of a bluish color as the gradient goes up. Goes down, so it gets darker as it goes down. That's what that's saying. And then I just multiply that by the actual gradient, plug that into albedo. We don't need emissive, but if you're doing a day-night cycle, you're probably going to want some emissive in your clouds at night, unless you have a second object like light scattering through the clouds like a moon. I'm not going to be covering that in this video. And then this under volumetrics, this is a new node, and this is essentially the crux of what drives everything for how the clouds render in the sky. So this is a new node called the volumetric advanced output. And then I'm not going to go through all of these settings here. I don't understand the science behind some of these fully yet, and I'm still learning. But as I said, all of this will be provided for you on my Artstation. You can get it for free, and you can just use these values that I set here, and since they're scalars, you can tweak the values and see how this changes how your clouds render when you're playing around with this, if you're interested. And all that does is that generally just makes our volumetric clouds. But the issue you can see here is, one, that it's static, and two, that it's just going all the way through our volume and it's very low resolution. So what we can do to up the resolution is the same thing that we do for a lot of 2D noises, is we can just take either the same noise or a different noise and tile it more and then blend the two together. And that's what I've done in the second material, Cloud Breakup, so let's add that now. You can see we're getting a lot more of that fluffiness in clouds that you're used to. Kind of looks like a powder or a flower. And although that's good, the only issue we have is that it's, as I said before, it's going through the entire atmosphere, like the entire cloud layer. So we're going to want to have more control over our clouds, but before we go further than that, let me show you here. All I've done is, just like before, I've got one clouds which is tiled huge, so this is our large clouds, and then one that is tiled an order of magnitude smaller, so this is multiplied by 10,000, whereas this is 100,000. And then I am just doing some simple maths to add them together, blend them together, and then again making it so the coverage is 0 to 1, and then adding some contrast, and then adding a maximum value for the clouds, and then everything here is exactly the same as what I showed you before. And that's what gets us what you're seeing now, this fluffy cloud effect. But what if we wanted to actually affect and have multiple layers of clouds? So what I used to build my layers of clouds is I looked at the Horizon Zero Dawn breakdown for how they did their clouds. And you can see they've broken down the different cloud types. You have the cumulonimbus cloud that goes through the full cloud layer from 0 to 1 in the cloud height, I guess. Then you have your lower level clouds, so we're going to make some cumulus clouds, or closer between cumulus and stratus clouds. And then in my demo that I showed you earlier, I had cumulus, cumulonimbus, and then I had some cirrocumulus and cirrus clouds. Just to break things up and have that kind of parallax effect of being able to see the multiple layers through the atmosphere really adds a lot to a skybox. So I'm just going to autosave quick. And now I can show you the next step, which is being able to limit everything by using curves and being able to affect the altitude of clouds. But before I do that, what I want to show you here is that I've actually loaded in a 2D world-aligned texture, which I've gone and made in Substance Designer. So let me show you this texture. It's a very simple, just channel RGBA channel pack texture. So red, I have this, which gives us all of our wispy shapes for the cirrus clouds up in the high altitude. Then we have, for the green, this is just a large clouds layer. And this is what I'm actually using to drive the, because this is tiling over such a large distance, I'm using this to drive the overall shapes of my clouds, so there's no visible tiling. And then for the blue, this dictates the cumulonimbus clouds. And what I have here is a linear gradient going from here to the edges. And this way it allows me to control the actual size of the clouds by multiplying this and having some contrast. So I can have a scalar that if I have it set to max, the clouds will cover the full sky. And then as I bring that scalar down, it brings them in closer to the center. And when I multiply that on top, that allows us to be able to control the overall width of these cumulonimbus clouds, sorry. So that's what that texture is, and it's only just a standard 2D texture, and I'm projecting it in the z-axis, so I'm masking the red and green from the world position. And then all I'm doing to get some altitude from that is I'm multiplying it by curves. I'll go over the curves in a second, and then I'm just doing again, so normalize everything values wise, and then I make sure it's clamped, and then I have a max density, and then everything here again is the same. So let me just save this and then wait for that. So let me move this down here, and if I add this to our volume clouds now, this cloud's altitude, what you'll see is there is a breakup here. So what this is the wrong one to add. Let's add this one, sorry. You can see how smooth everything, and that's because is, and that's because we're not using our volume textures anymore. But I wanted to show you that even though it's projected in the z-axis here, just using one like standard 2D texture, let me up my speed so I can fly through. You can see that it's still not, even though it's projected in the z, it's got some roundness to it. And the reason behind that is that I have a, if we look at the texture again, just the green channel, you can see how blurry this clouds texture is, and I did that on purpose so that there's a decent amount of range and softness in here for me to be able to tweak. And then in order to be able to control the actual altitude of these clouds, I'm using a curves, and it's actually this curve here. So you can add a curve atlas to your project, and then you can add a curve to that curve atlas, and you can access that atlas inside your material in order to be able to control the height offset of the clouds, and I'm doing that here in the material. So here's the curves that I'm using, here's the atlas, and then here's the curve. And then what I'm doing is I am taking this normal altitude layer that we're using to lerp the color over here, same node. And what we're saying is anything that we put in the curves between 0 and 1 will dictate wherever, since we're driving, we're having this from 0 to 1 drive it, we'll be able to control the altitude, fall off, and the shaping of each cloud in that 0 to 1 range. So here I'm using the red curve, and I'm simply multiplying it by the 2D mask here, the 2D noise. So if I show you the curve now, let me open that up actually here, and let's make it square just so it's easier to see the curve. And then we only want the red curve, so let's get rid of the others and select red. You can see it's here, normalized, focus. And what this is saying is, because we're using the cloud altitude from 0 to 1, min to max, to drive this, anywhere from 0 to whatever this value is here, 0.3, that's where the clouds will be. And you can see that if I tweak the clouds here, I can tweak their density and height. And also because the curve has shape to it, it's also and the noise has that softness to it. It also controls the shaping of the cloud, which I use a bit later, so I'll show you that for the cumulonimbus clouds. So I can make them more billowy, I guess, have their fall off more centered, but I like having them kind of have that sharp fall off and then go to a nice shape. But you can see that this is actually getting us a good base. So if I now take this, what I'm showing you before, this material which doesn't have any volume textures, and then I use this to multiply and combine with volume textures, what we end up with is these clouds altitude here. And there you go. So this is what I showed before by being able to have the 2D noise that's just in the X and Y, and then what I'm doing is just multiplying it over the larger noise that I'm using to generate the larger shapes, and then blending that with the smaller shapes, and then multiplying it by the altitude. So this is the same principle of what I just showed before, just with breakup in them to give them that fluffy effect that you expect from clouds. And if I go to the curves again here, and I tweak this curve at all, only the red one we need, and if I tweak this, you can see it'll update the clouds based off of the shaping of this curve. If I want them to go all the way to max altitude, I can. But there are limitations, again, to using a world-aligned texture, and it can cause some issues, so you need to be smart about how you use them. So if I go to Z-projected material here, if I didn't have that gradient, everything would be sharp, so let me show you here. If I wasn't controlling the altitude for these, and I just had it go straight to skip the multiply here, and then I plug this into the add, and then I hit save. What the 2D texture does is it essentially just projects directly down, since I've masked it on the Z. So you can see here, it just looks like it's cutting directly through from above. So you need to be careful with these, but you can use this to your advantage when it comes to shaping clouds, which I'll show you next. So now that's saved and out the way, let's move on to the next example. That's the fluffy world-aligned clouds, and now here's the clouds projections for the this is clouds projections demo material. So you can see the numbered in order. So what this is to show you that you can have different types of clouds, and in order to get this shaping, this is what I'm using for the cumulonimbus. Oops. This is what I'm using for the cumulonimbus clouds, which are the larger clouds that goes from the 0 altitude of the clouds all the way to max. Is not just can you control the altitude of clouds, because you can see this goes from 0 all the way to 1 max, and it never maxes out, it never bottoms out at that point. You can see that this curve is actually an odd shape, and that's because whatever I set this curve shape to, I'm actually subtracting it as it goes through that 0 to 1 gradient. And if you subtract that from it, you can see I can change the shape here, and you can do a lot with this. You can make like mushroom clouds if you wanted, but this is just a cool way to break up and control the shapes of clouds. This is just the best shape I found when I was testing just for these specific clouds. I've made maybe 4 different cloud materials now when I've been learning since this was released. And this is the one I'll be giving away. So these are curves here. You can see that curves directly, if you add or subtract them along the gradient, you can actually control the shape of that curve. Just like if you're doing it inside Designer or any 3D application. So from that, what we can get is, since this is the green curve, so the red curve I'm using for these lower clouds, and then the green curve I'm using for these larger clouds. And then in my material, that's where this curve is from. I have those cirrostratus clouds, which are high altitude, so they're closer to 1. And then we have those cirrus clouds, which are super wispy, and those are just all the way up to the edge of like almost to 1, so 0.969 to 1. So that's how I'm controlling the shape and altitude inside of this material using curves. I've seen a lot of tutorials that were using like exponents and getting quite technical with the maths, but I found that the curves is just way more art directable, and obviously you can have multiple curves inside of an atlas and inside your material and get a lot more complex than what I'm showing here, but this is just more for the principle side of things, so you understand the principles of how to make it. And again, that those volume textures are missing for some reason, so I'm just going to re-add those. So moving on to the next material from that, now that we understand how to use curves, we can go to our examples. So that was example 6, let's go to 7. Now you can see that if we take those shapes and then we just add that volume texture breakup again, we can get that stacking effect of multiple types of clouds, and then the types of noises that you use will dictate how the clouds look. So in this material, to get the large billowy shapes of the nimbus clouds, I'm using the green and blue of this texture because that has the billowy shapes in it. Whereas the red is just like your standard purlin noise, it looks like, so it's got much more wispy shapes. So understanding how your shapes that drive your volume texture and also your 2D textures will affect the shapes of your clouds will help you help you in the long run when it comes to putting your own cloud materials together. So there you go. Now we've done 7. We can add multiple types of cloud layers, control where they fall inside the cloud gradient to control different cloud types through the atmosphere, and we can break up those cloud shapes using volume textures. So the only two things really left principle-wise for you to understand to go and make your own cloud materials is how to move the clouds and then how to phase the clouds so they're not just moving in one direction. So we'll move on to material 8, cloud movement, and you can see here it's just nice, simple, just pushing the material in a direction, and you can control the direction by controlling the X and Y. And then you can convert that into rotation if you have a wind direction. So here it is. I've just added this extra little node group here. And all I'm doing is adding this to the coordinates of the materials. And all it is doing is taking an X and a Y and then multiplying that by time. And then I've got a slightly different multiplication per cloud type so that they're not all tiling at the same rate, so we can get some quite natural looking breakup as they're tiling at different rates through each other and blending together. And then same thing like I showed before, we just have this is simple maths that controls the cumulus. These are the stratus clouds with the breakup and just bring everything together, modulating by the tileable noise and then modulating the tileable noise by all this simple maths here. Although it is basic addition, subtraction, and a little bit of multiplication. And then all you need to do is to add them together and then make sure it's clamped, and then control your max density before you plug it into the final outputs. It's going to save and close that. We got the clouds moving. Then what is this last material? And I've just called this phase shift, because right now all we have, even though it looks quite natural, is we have clouds moving in our desired direction through the atmosphere. We also want them to make it look like they're rolling, and kind of, because clouds are a big fluid simulation, right? Like it's just fluid dynamics. We're not going to be doing a giant fluid simulation like that in our project. What we can do to make them look more like a fluid is to do the exact same thing that we were doing before by just adding time to the coordinates. But what I'm doing here is I'm also adding shapes to like the one of the clouds types to the coordinates after I've added time. So here what we're doing is we're taking the larger volume texture noise and we're just adding that to the coordinates at the end, and we're making sure to divide that by numbers so we're not going too high. Like here I've multiplied this by 1.5 and added that. That's how we do the tiling, but then I've got a parameter here that's set to 0.2, so quite low. that just multiplies, and then I mask components because this is a 2D texture, and then I just add that to the world align tiling noise here. And then I did the same thing, just at a much lower rate to the small detail noise to really break up those small shapes as well. So now if I close out of this, and then I don't need to save that because I know how the material works. Then we get this, and we can actually see the clouds shifting and kind of phasing. That's why I called it phase shift. And that to me just gave a much more believable result. So if I go to this material just one more time, and I'm just going to turn up the time scale on this. Just come to here, cloud speed. Let's just set this to something stupid like 5. You can see that it kind of looks a lot more like they're changing shape and kind of simulating, even though it's just a really simple trick. But you have to be very careful with the values that you put in this, because what could end up happening is if you go too high, is it's going to do that kind of gradient wispy thing. If you're going for like some cool stylized smoke simulation, and if you have a volume, this might be pretty cool. But that's essentially the last thing that I needed to show for you to break down for you and show for you to be able to make your own volumetric clouds. So now I'm just going to close out of this, and then I've got everything nicely named and organized inside this folder structure. So we're just going to take my volume texture, which is currently broken again. So let me just fix that because of that missing texture. There we go, fix my material. So I'm just going to now apply my material instance to this, and this is how my final clouds material looks. And then I'm going to open the instance so we can control that. And I've made a lot of parameters. I've exposed a lot of parameters here just so we can really control and art direct the clouds. Like you can control the density of each layer individually. So we have our stratus clouds here. So let's go to our stratus amount. The more there is, the more it goes until it's max. Sorry, the stratus coverage. From 0 to 1, 0, no clouds, 0.5 should be some coverage, and then 1 is full coverage. And then that's the same thing for the cumulus, but that's dictated by the size. Like I said, that gradient had linear fall off, so you can control the size of your cumulus stratus clouds here. And the breakup of them and the max density, and so there's a lot of control here, and I'll walk you through the final material now. And you'll see it's familiar to everything I just showed you before. We've got our noise panning, and then we have our phase shift, just adding the noises together, just what I showed you in the material before. We have our cumulonimbus, and then I just have two different material, two different cloud types that weren't in the others before. That's our altitude control. We have our cirrocumulus, which is just high altitude using a curve to control theirs, and then a cirrus, which is just using the red channel of that 2D tileable to make it look wispy, like I can show you again. This to get those high altitude wispy clouds. And then all I'm doing is simple adding, and then one of them I blend by a max, and then adding again, and then make sure I saturate, choose the max density, and then all of this again is exactly the same. So I don't want to save that, I haven't done anything to it, but you can just go through and control each of these layers individually. You can take a lot more care in naming parameters and setting parameters up, but this is just quickly thrown together for the purposes of demonstrating how to make volumetric clouds for the tutorial. So now we have clouds, we have them interacting with the atmosphere, and not just that, because of the new dynamic skybox and the way that the clouds scatter based off of that volumetric node, as we can move the sun, and it casts shadows inside the clouds on themselves based off of how they scatter light. But you can see that they're not casting any shadows anywhere else, and that's because we have to change some settings in the skylight, in the directional light, sorry. So if we go to the directional light, and then scroll all the way down, we have some atmosphere and cloud settings here. So cast shadows and clouds, it means that the clouds cast shadows on other clouds, or it casts shadows from objects onto clouds, sorry. And then cast shadows on atmosphere, and then cast shadows, cloud shadows will mean that if the sun is behind a cloud, it'll cast a shadow on the ground. So if we enable that, you can see that it actually does a really good job at that, although the resolution is quite limited due to the shadow resolution. You can up that a little bit, obviously at a performance and accuracy cost. And yeah, you can see my clouds. We have the different layers. You can see the wispy clouds up high up, and you can control the fall off of each layer. And this is the new volumetric cloud system in Unreal Engine 4.26. And then just to show you that it is really well done optimization wise, is let's go to lit and buffer visualizations, optimization, sorry, and then shader complexity. And you can see the only area where it gets expensive is where the lighting is casting the max amount of bounces through the volume. But everywhere else is relatively low. And this is dictated largely by our sun angle. So you can get it quite performant by just not having the sun at a strong angle. But obviously it's quite easy to now make a day-night cycle, because all you have to do is move the sun and everything automatically updates. You don't have to do a lot of changing of values. So now let's go back to lit. And then to show how this ties in with our atmospheric sky system before we call this all done, we go to our sky atmosphere. You can really control the feel of the sky as well, because I feel that this is looking quite good, just a little bit noisy, and you will get some weird banding due to the I believe it's due to the bit depth of the shadows and textures casting shadows. So you're going to want to play around with your settings and your directional light. For example, if it's your cloud shadow strength that will control that the most. So if you get rid of the cloud shadow strength, there's none of that. So it's due to the limitations of the shadow casting resolution. So let's get that back up, but it's now visible. I'm not sure how well YouTube shows that off, but you will find it in your own testing. And then in the sky atmosphere, if you want to get more God rays, so let's go here and turn the stratus coverage up a little bit, so that there's a lot more cloud cover, so only the sun can come through a few angles. And now if we go to, since we don't have a atmosphere fog anymore, we only have the atmosphere, the sky atmosphere. This essentially does the same thing with the Rayleigh scattering over distance and the different types of scattering, like your me scattering and your Rayleigh scattering. And you can control those all in here by, I like to turn the Rayleigh exponent distribution up a little bit to get more of a stylized scattering. I usually go 10 or 12. You can see a little bit more going on there. And that'll push things more towards red, the more scattering there is in the atmosphere. So if you want to make more of an Africa sky, you'd want to turn that up and tweak the values a little bit, and your Rayleigh scale here to get more stylized, softer looking atmosphere with more fog. And then the me, which is MIE, me scattering. This is your closer up stuff, so if it's raining and a lot in your game, or if it's like a sandstorm, you've got your, oh sorry, that's Rayleigh, me. If it's like a sandstorm or raining, you got your me scale here, which is just the density of your local atmosphere. And you can see the more you turn that up, it's actually also casting God rays. So it doesn't just cast shadows, it also casts God rays through the fog. So all of this is very, very dynamic and controllable. And then in your volumetric cloud settings, you can control your bottom altitude for the clouds, or have them go as high as they need, or the max like density height of the clouds if you want to get more cloud layering through your atmosphere. But the more the thicker your cloud atmosphere, the worse it's going to be for performance, as it has to scatter light through a larger volume, but depending on your light position, it will affect performance more. So and again, if you're taking that into mind, the size of your sky atmosphere and the size of your game level, all of the parameters for this material regarding cloud size here are all easily tweakable as well. So you don't want a cloud being, one single cloud being larger than your entire level, because if that goes over, all you have is a grey sky. So being able to tweak the size of the clouds for your skybox to match whatever you're working on is also a really powerful way to help with art direction. And there you go. That's the volumetric cloud system inside of Unreal 426. As I said, you can get all of these on my Artstation store for free, because I'm using volume textures that I didn't make, and this is for educational purposes. Feel free to use what you learned from this and any of the files that I made that I'm giving to you materials wise as well. For anything you want, there's no limitations there. Just I hope this helped you, and I hope you liked it. So if you did, give the video a like, and if you make anything cool with this, feel free to tag me and at me on Twitter. Always give me a shout. I'm always excited to see what other people are making. So that's my volumetric clouds breakdown and kind of principles for Unreal 426, and I hope you found this useful. Have a good day.